All right. So number 50 has quite a big mess to it. Um, again, I would see why somebody might think that maybe 2x is going to be u because it is trapped under something, but hopefully you don't have to write that down to see that that's not going to be helpful to get anything else. Like picking 2x as your u is just not going to get you anywhere. So in this case, I'm going to say u is probably this guy, the exponent on e. And again, I never really know until I take a step or two. So derivative, derivative. So what's the derivative of tangent something? Secant squared of that something times the chain rule. And now that should make sense why there's all of this crazy stuff. Like now I picked a better u, so now it makes more sense that these things will fit together. So what I've currently done is I've called this e to the u. And right now I've got 2 that I don't want. So if this is what I really want, I can see I'm dividing this side by 2. So that's fine. Just divide the other side by 2. And in place of all of that, you can put 1/2 du, since those things are equivalent. So again, the whole point of u substitution is to go from something really complex, hard to manage in our head, to something that should just be undoing the power rule or undoing stuff we have memorized. Raise the power by 1, divide by the new power, put a plus c. Okay, except that's not a 4, that's a u. Still a u. E to the u is still e to the u. And then substitute this guy back in place of u. And then that matches what they've got. So all things considered is actually kind of an easier one, assuming that you remember the derivative of tangent is secant squared and you remember the chain rule. So don't always go off appearance. To me, I thought this one might be harder.